All right, let's look at some of these problems. 5, is that the first one we have? Ah, no, it is 1. Okay, here we go. Simplify the ratio, 33 to 9. What is that? First, what's the first thing we should do? Write it as a fraction. In other words, that means the same thing as that. Now, can you simplify that? Is there anything you can divide top and bottom by? About 3. What's the top divided by 3 equal to? What's the bottom divided by 3 equal to? That's what you have to have the answer. You would definitely lose points for that. Okay, the next one is 125 over 25. Does that simplify? To what? Yeah, very good. I thought you were going to say 5, and I was going to say put it in a ratio. Okay. On 3 and 4, solve the proportion. I'm not quite sure what they mean by that. I assume they mean solve for y and solve for x, right? Yeah, okay, that's what they mean. How do you solve for y on 3? When you see a fraction equals to another fraction, think cross multiplication. I'm going to multiply those together to get y5 or 5y, and I'm going to multiply 10 times 2 together to get 20. Now what's y equal to? Yeah, and if we look at that proportion, we'll see that 10 divided by 4 is the same as 5 divided by 2. So you can kind of check it. Okay, use the same technique on the next problem. Okay, good. Well, you're close. It's 4 times the quantity x minus 6 equals 6x. And if you don't use the parentheses sign here, you're going to get it wrong. You got to put, in other words, you got to cross multiply. You got to multiply 4 times this denominator, which means putting those two terms inside parentheses. Now what? Distribute is what that's called. Distribute the 4. What do you get? Okay. Yes, absolutely. So tell me the next line. Okay, I like to go from left to right. Okay, so I wanted to make sure that you put the negative sign in front of the negative 24. That's why I said read me the next line. So when I move the 4x over, I get this. Okay, now what's the last line? Okay, so what is it? So what's the answer? Yeah. And I'm not sure we have to necessarily answer it, but does negative 12 work for that? If that's negative 12, and that's negative 12, what's that become? Okay, so you have 6 over negative 18. Is that equal to 4 over negative 12? Actually, it is. In other words, I can actually simplify both of these. I can divide this one on the left by 6, top and bottom, to give me 1/3. And the one on the right, I can divide top and bottom by 4 to give me negative 1/3. Okay, let's just talk about something. Let me make sure you understand this. Minus 1 over 3 is the same as 1 over minus 3, which is the same as the minus sign being in front. This is actually the answer I prefer myself. The minus is not going with the 1. I meant to put it right there. Okay? In other words, the minus is just in front of the 1/3, like that. So whenever you see this, where you see a negative sign on either the numerator or the denominator, you can always move it out in front of the fraction. All right, let's scroll down to 5, where we have triangle dog and triangle cat. And they are similar. Yeah, tell my dog and cat that. What is y? What? That doesn't make any sense. Their question doesn't make any sense. Yes, it's AT is what they're looking for, right? DG, yes. Now that makes sense. So how do you do these kind of problems? When you have similar triangles, we're just finishing the labeling of these triangles is what we're going to do. I don't care what they call it. But we know the triangles are similar, so what's the first thing we need to write? We need to find a side that's the corresponding side. Okay? What are the two sides that are corresponding sides in these similar triangles? They were nice enough to lay the triangles out perfectly oriented for us. So what are the similar sides? Correct. So I don't know what your teacher likes to do, but I always like to do the big over the little. In other words, that is called the scale factor. Okay? And a scale factor between similar figures, whether they're triangles or anything else, is the ratio of the bigger side to the smaller side of corresponding sides. You can't compare the 5 to the 8, but you can certainly compare the 5 to the 4. And notice they did not draw this to scale. Notice in their dog triangle that 8 is a smaller side than 4. Doesn't matter. They didn't need to draw it to scale. We can see that dog is similar to cat, which means the 5 side is the similar side to the 4 side. So this is our ratio. This is our scale factor right here. Okay? Now, if that's the scale factor, how do we figure out DG? Give me a ratio, a proportion that I can write. What is 5/4 equal to? Let me call that X for the moment. Well, think. In other words, I got the 5/4 by comparing that side with that side. So these proportions are the same within two similar triangles. Whatever scale factor you come up with, it applies to all the other sides also. So it has to be the same as 12 over x. Now solve that. What's x equal to? Just, yeah, no, it doesn't have to be decimal. This is actually a better answer anyway, ratios. Ratios are the language of trig. Not that you're taking trig yet, but you'll get a little bit of trig this year. And ratios are better. I do not want to turn that into a proper fraction. I definitely don't want to turn it into a decimal. It's fine exactly the way it is. Okay? So that means that DG is 48/5. And if you check the ratio of 12 to 48/5, you'll find it to be exactly the same as the ratio of 5 to 4. Now, let's figure out why. So give me a proportion that will allow me to figure out why. Start with our original scale factor. I can't tell you how important it is to come up with the scale factor. And once you come up with it, don't forget it. What was the scale factor? It was 5:4. That was the scale factor. This triangle right here on the right, cat, every side of it is exactly 5/4 of triangle dog. Okay, so what does that mean? That means if that's my scale factor, how can I relate y with 8? Write it as a ratio. Think ratios. So y divided by 8. In other words, I got 5/4 by taking 5, dividing it by 4. Well, that means that y divided by 8 has to be that exact same ratio. Okay? Now, solve that. What's the easiest way to solve that? In this case, the variable's in the numerator. I don't really need to cross multiply. Notice what happens if I have to cross multiply. I can do it, but it's not necessary. I get 4y equals 40, and then I have another step. I got to divide both sides by 4 to come up with y equals 10. But notice what happens if I don't cross multiply, and I just multiply both sides by 8, then it's one step. That's equal to y. I don't need to cross multiply. Cross multiplying is a little self-defeating because why do I want to multiply 4 by y when I have to, the next step, divide it by 4? So I don't do it. And that's equal to 10 because I divide top and bottom by 4, giving me 2 times 5 is 10. Now, let's talk about something else about similar triangles. It's very important. Not only are each side of cat the same proportion to each side of dog in a 5:4 ratio, but another thing is true, and that is that this side is, excuse me, hold on a second. This side is to that side as this side is to that side. In other words, it's not just the ratios between the triangles that are the same. It's the ratios within each triangle. In other words, I can say 8 is to 4 as y is to 5. Well, what does that make y? 8's twice as big as 4. Yeah, and that's actually a much faster way to come up with AC. Okay, now it's not so easy with DG. I could have done it that way also, but you have to establish the scale factor. You can't do anything with these problems until you get a scale factor. And in order to get a scale factor, you have to have the corresponding side. You know what I mean when I say the corresponding side, right? Kind of. Do you have any trouble telling the corresponding sides in these two similar triangles? Okay, that's all. You need to be able to know that that corresponds with that. Those are the two corresponding sides. That corresponds with that, and the hypotenuses correspond with each other. So the corresponding sides are the ones I just marked. And they each have a scale factor, and it's the same scale factor. If I'm comparing DF to AC, same scale factor as EF to BC. Also, the scale factor between AB and AC is the same scale factor as the scale factor between DE and DF. In other words, if that was 2 and that was 8, and I said this is 4, I can see that 8 is 4 times 2. Therefore, DE has to be 4 times 4. So I can do it simple like that. And that was actually the simplest way to come up with AT, was to recognize that 8's twice as big as 4, so this has to be twice as big as 5. And I didn't have to use this weird fraction of 5/4. So sometimes it's quite a bit easier to do it the other way. Similar trapezoids. Now, in this case, they weren't quite so nice. They didn't orient it perfectly. They rotated one of them. Tell me what the corresponding side to that side is. Okay, there's your scale factor, big to little. Now remember, you can always go little to big. It does not matter. It's just that I find big to little more useful because that produces a number greater than 1. Whereas if I go 8 to 20, now I'm dealing with fractions. Okay? And this is sometimes a fraction, but sometimes it's not. Okay, so I've got to solve first for this side. What is the equivalent side for x? Yes. So what's the rest of this proportion? 20 is to 8 as a what? It's x is to 11. You got to make sure you go in the right order. In other words, this is big to little, this is big over little. X is bigger than 11. It's the bigger trapezoid. Okay. Now, solve that. Not by cross multiplying. Just solve it for x. In other words, all you need to do is multiply both sides by 11. So you have 220 over 8 equals x. Now reduce 220. I'll tell you an easy way of reducing that. Cut top and bottom in half. Now do it again. And there's your answer. That is x. That's the length of x. Now notice that I did it the easy way. You can always cut stuff in half. But I had to do it twice, which means I really could have divided top and bottom by 4. In other words, what I did was divide top and bottom by 2, and I did it twice. So I could have done it just starting off dividing by 4 to come up with that in one step. Okay. All right, so we got x. Let's label that 55, 20 over 2's. And that kind of makes sense. This trapezoid is 2.5 times this one. 2.5 times 11 is about 27, which is 55 halves, 27.5. So that fits our ballpark. In other words, I always like to do a ballpark check when I'm doing these kind of problems. Had I come up with an answer of 552, I know I'm not in the ballpark. Okay, but when I come up with an answer of 27.5, that's about 2.5 times 11. So, and that's what I'm looking for. I'm looking for a 20:8 ratio. Okay, now, because they are similar, let's see, we got to solve, let's solve for y next. What is our scale factor again? Take two corresponding sides, make them a ratio. That's our scale factor. Okay, so let's solve for y. Perfect. Now notice that y is in the denominator. This is where you have to cross multiply. You can't get away with just one multiplication here because I got to get y into the numerator, which means I do have to cross multiply. So do you have a calculator in front of you? Multiply 8 times 27.5. Okay, and then when I divide that by 20, I get y equals 11. So that's 11, and that's 11. Ah, look at that. That's 27.5. That's 27.5. This is an isosceles trapezoid. In other words, the two non-parallel sides are equal. It's kind of like an isosceles triangle, only it's an isosceles trapezoid. So the fact that it's an isosceles trapezoid makes this angle what? Okay, so if that's 115, what is z? Now, remember, let's draw this triangle or this trapezoid in a more conventional manner like that, where this is 8 and this is z. And this is 3, and that's 11, and that's 11. So as all I did was I took this trapezoid and rotated it so that it would have the same orientation as our big trapezoid. Okay? So the angle we're looking for is that one. Angle 1 is the same as Z. When you have similar figures, all the angles are the same if you can find the corresponding angles. And I've drawn it oriented perfectly, so there's no question 1 is the same angle as Z. So what's 1? The two adjacent sides of a trapezoid between the parallel lines are supplementary. So 1 is 65. In other words, 65 and 115 have to add to 180. So if 1 is 65, then Z is 65. And now you've solved for all their variables. Oh, I even like their questioning here down here. Find the scale factor. That's always the first thing you try to do. Now you can only find it if they give you two measurements of two corresponding sides. And they did. They gave us the biggest side of the trapezoid and the biggest side of that trapezoid. So that's our scale factor, 20 to 8. And you could simplify that to 5 to 2. Not that you necessarily have to. I'm not sure you have to simplify scale factors. The only reason you use a scale factor is to find out the other side, so it's never a final answer. Although in this question, since they did ask for it, it is a final answer. So let's simplify it. Let's call it 5 to 2. I really should have done that to begin with, just because it makes the math easier. Instead of using 20 over 8, if I use 5 over 2, all the math's going to be a little easier. So I found the values of x, y, and z. So that's 11. What's the perimeter of the little trapezoid? So 11 plus 11 is 22, plus 11 is 33. It's 8 plus 3 is 11, and then I got 2 more 11s. So I got 3 11s, 33. Okay? Now, the perimeter is a linear measurement. So the scale factors of the perimeters are going to be the same as your scale factor. So what's the perimeter of the big trapezoid? Five over 2 times what? What was the perimeter of the little trapezoid? So it's 5 over 2 times 33, which is 165 over 2. Can't simplify that. That's the answer, 165 over 2. In other words, because perimeter is a linear measurement, you measure it in feet. You don't measure it in square feet. Okay? The fact that it's measured in feet makes it linear, and the same rule applies on the scale factor. If the linear scale factor is 5 to 2, then the perimeter scale factor is 5 to 2. However, the area scale factor is not 5 to 2. Area is two-dimensional. It's measured in square feet. So the linear, it's useful if you call this the linear scale factor, because that's the scale factor between sides that are measured in a single dimension, like inches or feet. Whereas area is square inches or square feet. And believe it or not, the scale factor for the area is not 5 over 2. It's the square of 5 over 2. It's 25 over 4. That's almost 6 to 1. The area of this trapezoid, even though the sides are in a 5:2 ratio, 2.5 to 1, the area of that trapezoid is 6.25 times the area of that trapezoid. In other words, when you go from linear to area, you square everything. If I'm going to volume, I'm going to cube everything. So this scale factor that I'm talking about here is a linear scale factor. Nothing more. It's just a linear scale factor. It's the ratio of every side to its corresponding side, and it's the ratio of the full perimeter to this full perimeter. All right. Moving along. Determine whether the two triangles are similar and write a similarity statement. Are the first two on the left, on number 7, are they similar? Very good. We do have to label this. What's angle F? And what's angle D? What's angle D? So why are they similar? Angle, angle, angle. Same 3 angles. This is 90. That's 90. They have 3 unique angles, 90, 42, and 48. Both triangles have it, therefore they're similar no matter how they're positioned. I could draw this like this if I wanted to. Well, I won't even try. You don't need to have them oriented properly. As long as you knew that all 3 angles were the same, yeah, I could draw this one like this. Okay? Wouldn't matter. As long as I know that's 90, that's 42 and 48, or even if that's 48 and 42, it wouldn't matter. As long as all 3 angles are the same, they are similar. Okay, how about number 8? And the 2 triangles they're talking about in 8 are this one and this one. Okay, are those similar? Correct, because that's 65 degrees and that's 65 degrees. So they have at least one angle that's the same. This angle is in both triangles. So they have 2 angles that are the same. And in reality, is all you need to prove similarity is angle, angle. Because if 2 of the angles are the same, then all 3 of them are the same. Because once you know 2 angles of a triangle, the third one is automatic. In other words, if 65 is equal to 65 and what is that, a B? S is equal to S, then this angle is equal to that angle because all triangles add to 180 degrees. So if 2 of the angles are the same, then the third one has to be the same also. So we really do have angle, angle, angle. And I'm not quite sure what he's looking for when he says write a similarity statement. I presume he's saying based on what are you calling them similar? And in both cases, it's angle, angle, angle. All right. Okay, let's go up and pick up the ones on the right, starting with 9. So when you're given a problem like this, it's a good idea to always, if you're not exactly sure how to do it, it can never hurt drawing a picture. They say the perimeter. Well, not only do I want to draw a picture, but they have not given me any lengths at all. They've given me a perimeter, but that's all. Okay? So I'm going to start calling these variables that I have to solve for. Okay? You with me? Okay, the ratio of the length to the width is 4 to 3. Give me an equation involving y and x that I can write. Don't sound so unsure of yourself. You know this. Is equal to what? Correct. Okay. There's one equation, but it's got two variables in it. I can't solve it all by itself. So I got to come up with a second equation. And I can do that from that first sentence. Based on x and y, what's the perimeter of this thing? Yeah, but so 42 is equal to what? That's also y, that's also x. Add the four sides together, that's the perimeter. So what is it? What goes on the left side of this equation? Add the four sides together. Well, how many y's do you have? How many x's do you have? There you go. It's that simple. Okay. Now, I got a second equation. I got two equations and two variables. I can solve it. What's a good way to solve this? Here's my one equation. There's my second equation. How do I come up with what x and y are? How do I solve this system of equations? And this is more of an algebra problem than a geometry problem. But, as you found, geometry is at least half algebra. You don't get rid of algebra just by going to geometry. It just you come across it more. How do you solve these two equations? X over y equals 4 over 3. That's one equation. And 2y plus 2x equals 42. I got to solve that system of equations. There's two methods to solve a system of equations: substitution and elimination. This one doesn't lend itself to elimination very well, but it does lend itself to substitution. But in order to use substitution, you got to have one of the equations solved for one of the variables. So let's solve the top equation for x. What's x equal? Solve that for x. How do you get rid of the y? How do you get it away from the left side of the equation? You multiply both sides of the equation by y. In other words, I multiply the left side by y and I multiply the right side by y. Those cancel, leaving me x all by itself equals 4y divided by 3. So that's what x is. And now I can substitute that in the second equation wherever I see x. So we got 2y plus 2 times 4/3 y, that's what x is, equals 42. And now notice, now I have one equation and one variable, I can solve it. I get, let's simplify that a little bit, first of all, by dividing both sides by 2. If I do that, I get this. You with me? Make sure you follow every step I'm doing here. Okay, now combine the y's. What do you get? What's y plus 4/3 y? No, you're adding. I got one apple, that's the y, and I got 4/3 of an apple. If I combine one apple with 4/3 of an apple, how many apples do I have? Put it in an improper fraction. It's too difficult to deal with proper fractions in equations. It doesn't work. So make that an improper fraction. What is 1 and 4/3 equal to? One is 3/3. So what's 3/3 plus 4/3? Okay, so now we have 7/3 y equals 21. Solve for y. Okay, let's talk about solving equations. Because you can't do geometry if you don't know how to solve simple equations. And these are simple equations. Okay, so I'm going to have to back up here. When you are solving an equation, what you're trying to do is get rid of everything that's not what you're trying to solve for. Okay? So if I have 7/3 y equals 21, what am I trying to get rid of? I'm trying to get rid of the 7 and the 3. How do I get rid of the 3? You always do the opposite of what the number is doing. Right now that 3 is a divisor, right? So how do I get rid of it? Multiply both sides by 3. If I multiply both sides by 3, that gets rid of this 3. Now I got 7y equals 63. Now how do I get rid of the 7? If I can get rid of the 7, I will have my answer. The 7 is currently what? Is it being added, subtracted, multiplied, or divider? No, it's not dividing, it's a multiplier. That means you have to divide. In other words, what you have to do to get rid of it is the opposite of what it's currently doing. What it's currently doing is multiplying. So I got to divide by 7, both sides. Now, if those go away, I get y equals 9. So I've solved for one side of this thing. Okay, and I had this to begin with. It was in a 4:3 ratio, the length to the width. So if I know y is 9, solve for x. Plug in 9 for y and solve for x. Give me the equation. First write it. Always write the equation and then solve it. Don't try to do both at the same time. Probably the biggest mistake people make with math is trying to do multiple steps at once. And they just can't do it. But if you do it one step at a time, it's real easy. So substitute 9 for y and tell me what to write. No, substitute 9 for y. So it's x over 9 equals 4 over 3. Now solve that for x. What's the thing you got to get rid of? What do I have to get rid of to solve for x? You got to get rid of any other number that's over there. What number is over there? No, it's on the same side as the x is. Okay, that's what I got to get rid of. What's the 9 currently doing? So the adder, is it being added, subtracted, multiplied, or divided? No. What is the 9 currently doing? Correct. It's dividing into x. So what do I have to do to get rid of it? You have to do the opposite. If it's currently dividing, you got to multiply. You always do the opposite. If it was currently being added, I would have to subtract. If it was currently being subtracted, I would have to add. It's currently a divider, so I got to multiply both sides by 9. And those 9s will cancel, and I'll be left with x. Now, what's that equal to? 4 thirds times 9. That's the hard way to do it. I would much prefer you do this by simplifying the 9 over 3 first. In other words, I can divide top and bottom by 3. That'll go to 1, that'll go to 3, and now the answer becomes 4 times 3. Notice that I got the same answer as you did, but the biggest number I had to deal with was 9. You had to deal with 36. Now, if you're using a calculator, it probably doesn't matter. But a lot of times you're going to have to do these without a calculator. They're not always going to let you use a calculator for math problems. And when you're doing something like this, you always want to simplify before doing that. And I can see that I can divide top and bottom by 3. I can divide that by 3 and that by 3. This becomes 1. This becomes 3. Problem becomes 4 times 3. So y is 9, x is 12, and our garden looks like this. 12, 9. It gives it a perimeter of 42, and it makes the length 4 thirds the width. 12 to 9 is the same as 4 to 3. So we've solved it and we've checked it. Okay. I got a 7:30, so I don't have a lot of wiggle room here. Let's see how quickly we can do 10, or if we can do it quickly. And we'll start it. One serving calls for 2 cups of sugar. Wow, that must be a big cookie. Are you kidding me? 2 cups of sugar? That is a ton of sugar for one cookie. Okay, if Oh, I see. One serving makes enough for 3 people. That's still a lot of sugar per person. How much sugar is needed to serve 10 people? Well, first of all, how much sugar is used in one serving? Okay. How much do we have to increase our serving by to feed 10 people? Well, what's the ratio? What's the ratio of the people we're trying to serve versus what we know it takes one serving to serve? 10 to 3, is it not? In other words, this is how many more people. We're going to have to serve 10/3 more than 1. So how many cups of sugar is in one serving? So we're going to have to multiply 2 by 10/3, the ratio of the 2 people, the 10 people versus 3 people. That gives you 20/3 cups of sugar. Okay. An easy way to look at this would be, what if I was serving 6 people? Now you don't have to use any math. If I had to serve 6 people, how many cups of sugar am I going to need? Yeah, so you were able to do that just intuitively. You knew that 6 people was twice 3 people, so I'm going to need twice 2 cups. Well, 10 people, if it was 9 people, I would need exactly 3 times as much, right? So what I'm always doing is I'm taking the ratio and multiplying it by the number of cups used per person. So for 6 people, it would be that. For 9 people, it would be that. And for 10 people, it's this. In other words, it's that ratio times the number of cups for 3 people. 3 people require 2 cups. All right. Brandon, I'm going to let you go. You have a good evening, and I will talk to you next time. I'm sorry, what? Yeah, okay, it's $36. I can send an invoice that gives you all the information as to how to pay. You want me to send it to your mom, Mimi? I think I have her email address. Let me just take a quick look. I got your email address. Oh, that's the one she uses? Okay, so I can send the invoice to brandondang9@yahoo. Okay, and I'll probably get that out tomorrow. I'll send it to you. And yeah, these are recorded, and you already know how to get to your recorded version, I think. Okay, Brandon, I'll talk to you next time.